Hello class, hope you guys are doing well today. So today we are on lesson 5.2 and we are going to deal with polynomial addition and subtraction. For the first few problems we're going to use the algebra tiles, so you should have those out. And we are going to use them together, okay? I'm going to do my best to show you how I would use the algebra tiles by drawing them out on the board. So the I can statement today is I can add and subtract polynomials by combining like terms. It's really like terms, and so when we use the algebra tiles, we're going to see what things are alike to combine them as much as I can. Okay? So let's look at the first problem right away. We are told to add f of x and g of x. So the first thing I'm going to do on a problem like this is I'm going to replace f of x with what f of x equals. And f of x equals x squared minus 7. So instead of f of x, right below there, I'm going to replace it with x squared minus 7. Okay, and I'm going to put it in parentheses. The parentheses are really important when we get to subtracting. So we're going to put them every time, though, to be careful. So right away for f of x, I have x squared minus 7. Then I'm going to put a plus sign because I'm adding g of x to it. And in place of g of x, I'm going to put 4x squared plus 3x plus 1. So when I add these two together, I have x squared minus 7 plus 4x squared plus 3x plus 1. So what I'm going to do now is I'm going to draw out what I have. For the first thing here, I have an x squared. Remember, an x squared is one of those squares. So what you can do is pull out one of your big x squared squares, because I have one of them. Okay? Then it says I have minus 7. Minus 7, remember, these are constants. They're all the little 1 pieces for the algebra tile. So I have negative 7 of those. We should have 7 of them, and they're all on the red side for being negative. Seven of those total, 7 negative ones, okay? So that's the first part of this problem, okay? Then what I'm doing is I am adding this other thing to it. So I'm adding now 4x squared. So I have 1x squared, I have my second x squared, I have my third x squared, and my fourth x squared. So 4x squareds from that second one. Then I have 3 x's, and remember the x terms, those are the long ones. They're kind of like a stick, okay? So I have 3 of those. I have 1, 2, and 3. Again, it's positive, so it's on the colored side, not red. And then lastly, I have plus 1. And again, that's positive. So I would have that on the positive side. So plus 1 little 1. Okay? When I'm adding these together, I'm going to put like things together. So first off, let's look at just the x squareds. When I look at all those together, how many x squareds do I have? Well, first of all, I see I have 1 over here plus 4 here. So total, I would have 4x squareds. Okay, so that's the first part of my answer. Or sorry, not 4. I have 5x squareds. 5 total x squared. So that's the first part of my answer. Now I want to look at how many x's I have. Notice I didn't have any x's, any orange pieces in my first equation, but in my second equation, I have 3. So then I have plus 3 x's. Total, I have 3 x's. Okay? Last thing I got to do is I have to look at my 1's. And this is where it gets a little bit different. Okay? So here, for the red ones, those are all negatives. I have negative 7 ones here. But then I have plus 1. So if I have negative 7 ones, but I'm adding 1 to it, how many do I have? That's what we should be thinking. Negative 7 plus 1 would be negative 6. Basically, one of the negatives cancels out the one positive. Those cancel each other out, and I end up just with negative 6. Okay? So that's how we look at it with the algebra tiles. I combine things that are alike and cancel things out if they are opposite signs. this here would be my final answer. 5x squared plus 3x minus 6. All I'm doing is combining things that are alike. Okay? Let's look at the next example. Okay? Now it says we're adding g of x plus h of x. Now, if you like the visualization of the algebra tiles, keep using those. But on this problem, I'm not going to do it and show you how I would do it without using algebra. Okay? So I'm going to take and replace g of x with what it equals. It's 4x squared plus 3x plus 1. And again, I'm looking up here for that. Put it in parentheses, plus h of x. And h of x is x squared minus 5x plus 9. Again, I'm getting that from up here. Okay? So what I'm going to do is I'm going to combine the like terms. Okay? What I like to do is I like to think about each of my exponents as a different degree or a different thing. So one thing I like to let them equal is different sized bags of chips. Okay? So one thing I like to do is let the ones or the constants here, those are like little mini bags of Doritos. You know, the small ones that you get, maybe you bring in your lunches, your parents give you as a snack, something like that. The little bags, and I can only combine those things together. Okay? The things with an X, those I like to think of as maybe the regular sized bags of Doritos that you would get at the store. Maybe your family shares sometimes, those kinds of bags. Now the X squareds, those are the better bags yet. Those are the big family sized bags of Doritos, okay? And those are alike, and I combine those. So when I add all these things together, I don't want to combine the small bags and the large bags, but I want to tell individually how many large bags of Doritos do I have, how many family-sized bags of Doritos do I have, and how many small bags do I have. I want to keep it separated like that. So basically, I'm going to rearrange this so my x squared terms are together. I would have 4x squared from this first term plus x squared from the next term. Because those are alike, I can combine those. Okay? Those are my family-sized bags of Doritos. Now I'm going to go to just the regular-sized bags of Doritos. First I have 3 of them. Then I'm taking away 5 of them. Okay? And lastly, let's go to the really small bags of Doritos. First I have 1, and then I'm adding 9 to it. Okay? So now let's combine and say really easily how many I have. Okay? So we're only combining things that are the same color here. I'm only first going to combine the family-sized bags of Doritos. First I have 4 of them, and then I'm adding 1 to that. So total I have 5 family-sized bags of Doritos. Okay? Then let's look at the regular-sized bags of Doritos. First it says I have 3 of them, and I'm taking away 5. There I would have minus negative 2 of the regular-sized bags of Doritos. I lost those to a friend or gave them away. Now let's look at the really small bags. I have 1, and I'm gaining 9. So total there, I have plus 10. Okay, so basically what we're doing here is we're combining like terms. And one important thing we got to do is make sure we don't combine things that aren't like terms. X squared and x are 2 different things. And my final answer will have both of those. So in the end here, based on what we learned yesterday, is we have a polynomial of degree 2. It's quadratic, even after I combine everything together. And based on how many terms it has 3 terms, so that is called a trinomial. This is my final answer. Okay? So now I'm going to skip example C and I'm going to go to subtraction problems. Subtraction problems are very similar to addition problems with one extra step. Okay? So first, like we did before, let's write this out. Let's write out example A. A is saying take g of x, which is 7x squared minus 5x minus 1. I'm going to put that in parentheses. I'm going to subtract now the other term, f of x, which is x squared plus 8x. Okay, so I'm going to quickly write out how I would do this problem, and we can end up using algebra tiles if you want, okay? But one thing that this is saying is I am subtracting everything in this second term. I'm subtracting everything. I'm not only subtracting the x squared, which is why it is so important to put that minus sign. Okay? So really, when I think about it, if I wanted to put a number in front of the parentheses here, there is an invisible 1. So it's a -1 there. What could I do with that to help me figure out how I subtract everything? Well, I have to distribute or give to everything in the parentheses that negative. I'm going to multiply each thing here by -1 to show that I am subtracting both of those things. Okay? That doesn't change the first term because I'm not subtracting that. I'm only subtracting the second. So let's rewrite out what we have here. I have 7x squared minus 5x minus 1. That's the first term. Then I have minus x squared if I take -1 times x squared, and then -1 times 8x is -8x. Or -1 times positive 8x is -8x. When I distributed that negative to everything, since they were both positive, they both became negative. Okay? That's really important to do. Common mistake is only to make the x squared negative and not the 8x. You need to distribute that -1 to each thing. Okay? Now what I'm going to do is I'm going to underline my like terms. So first off, I have 7x squared. Does it have any like terms, I should be asking myself? And yes, there's a -x squared behind it. Okay, now let's look at x terms. First I have -5x, and I'm combining it with -8x. Those both have an x in them. Remember, they're the regular size bags of Doritos. And lastly, I have the -1 by itself. I won't combine that with anything. Okay? So let's rewrite it so that similar things are together. First I have 7x squared minus x squared. Those things are alike, so I write them next to each other. Then I have -5x minus 8x. Those things are alike, so I write them next to each other. And the last thing, the lonely -1, I would write at the end, -1. Okay? So let's combine these things. If I have 7x squareds and I take away 1, I would have 6x squared. If I have -5x and I take away 8 more, I have -13x's. And lastly, I'm just left with that -1. I cannot combine any of these things together because, like my analogy with the Doritos, they're all different things. I don't want to combine them and say they're the same. I have to keep them separate because they're separate things. Remember, the x squareds, they represent the squares out of your algebra tiles. The x's are the longer pieces, and the ones are the small little ones. They are different, so I don't want to categorize them all as the same. This is my final answer. I would leave it like this. Okay? Let's do one more of these subtracting problems, and I'm going to go to problem C since I ran out of room here. Okay? So again, like I did last time, I'm going to just fill in what h of x and what g of x is, putting them both in parentheses. So h of x is equal to x to the third minus 2x squared minus x plus 11. So it's x to the third minus 2x squared minus x plus 11. Put that in parentheses. We're subtracting again, because there's a minus sign between them. We're subtracting g of x. So g of x is 7x squared minus 5x minus 1. Okay? Again, like last time, the first step of the subtracting problem is going to be distributing that -1 to each thing in the parentheses. Okay? Again, that doesn't change my first set of terms. So it's x to the third minus 2x squared minus x plus 11. And then when I distribute this negative 1, I get negative 7x squared. Negative 1 times negative 5x would turn into a positive 5x. And the negative 1 times the negative 1 turns into a positive 1. Whenever I'm subtracting, it changes the sign of everything, and I do the opposite. Okay? Now let's rewrite it so that similar things are together. So the x to the third is by itself. I will write x to the third at the beginning. Next up, we have the x squared terms. Underline both of those and write them next to each other. Negative 2x squared minus 7x squared. The next terms that are alike are the x terms. We've got negative x and positive 5x. Negative x plus 5x. And lastly, we have the constants at the end. So we would have positive 11 and positive 1. So let's combine the things that are similar. So we get x to the third by itself at the beginning. Negative 2 minus 7, which is negative 9. Then we have negative x plus 5 is positive 4x. And lastly, 11 plus 1, positive 12. All of these are separate things. We have the 12, which is a constant, the 4x, which is the regular bag of Doritos. We have the x squared terms, which is the family size. Then we get the x to the third, which is something even bigger than that. All of these are different because they have different powers on their x's. So this is my final answer. I would leave it like this. It's my final answer because I can't combine anything else. There's no more like terms. X squared and x are different, just like x and y are different. I can't combine them unless they're like terms. Okay. There are a couple more problems that I want to do with you. Okay? So this problem, or these types of problems, are basically asking for the coefficients, or the numbers that we would put in here to make this equation true. So let's look at the first problem. Okay? So we have right at the beginning this x squared term. We have an x squared term in the second one. And together, we want those to add to be 5x squared. So basically what I need to ask myself here is, what would I put in this front spot here so that when I added it to 3x squared, it would equal 5x squared? The number is clearly 2, because 2 plus 3 equals 5. So I know right away to put a 2 in that spot. Okay? Let's look at the x terms next. Okay, so I have a 7x here, I have a blank x there, and an 11x at the end. So here I'm asking, what do I add to 7x so that it equals 11? Think about it for a second. The number I would put in would be a 4, because 7 plus 4 is 11. Okay? The last thing, the constants. Here we have a negative. Notice there's a minus sign there. Minus sign right there. Negative something plus 2 equals negative 13. So what negative number plus 2 would equal negative 13? And it would be negative 15. Negative 15 plus 2 is negative 13. So all these problems is trying to get you to think backwards and trying to find out what numbers would I have to have there for this equation to be true. So I'd have a 2 in the first spot, negative 15 after that, and then a 4 in the end. Okay? So lastly, let's look at problem B. Okay? We'll end with this problem. This problem's a little different because of the minus sign. Okay? Remember how it's different with the negative number. This will change the sign of everything in the last set of parentheses. Okay, so keep that in mind. But other than that, it's the same problem. First, let's look at the x squared terms. We got 3x squared, and we have blank equals 1. Okay? So, what would I subtract from 3, because it's a negative, I'm subtracting, to get 1x squared? The only number that works there is a 2. Because if I take 3x squared minus 2x squared, remember that changes the sign of it, it equals just 1x squared. Okay? Let's look at the next number, the x terms. We have just a blank x again. Then we have minus 5x equals 13x. What does this minus do to the negative in the parentheses? It really turns it and says this is a positive 5x. So what would I add to 5x to make it 13x? Well, that would be 7. Nope, 8. Sorry for my bad math there. 8 plus 5x is negative 9. Okay, and the last term is we have a constant. We have some number there equals negative 9. Now, a lot of times, since this is the only constant, I would think I want to put a negative 9 here. However, remember we have this minus sign in front. That is going to change the sign of the number in parentheses. So, I would want it to be a plus 9, because this negative here will make it a negative 9. Okay? So, be careful with the negative numbers. They switch the sign of everything in the second set of parentheses. So in this problem, problem B, I would have an 8, then a 2, then a 9. Okay? If you actually, in the end, do this subtraction problem here, you should get this as your answer. And that's a way you can check to make sure you did it right. Okay? The biggest thing here is making sure you have the signs correct. So that's all of this lesson for today. Work on your homework, and I'll be back tomorrow. So get to work, and I'll see you tomorrow. Have a good rest of your day.